So, okay, so what affects weather on our planet the most? Einstein's up there. He's going to help you out.
That's a tough thing to do to talk about, but I would say the atmosphere, because the composition of our atmosphere is what most processes driving everything stems from. You look at things like thermohaline circulation, which is, you have the globe here and you've got all these different land masses and all that. And you have, a country like England. England is extremely dependent on thermohaline circulation because you have warm waters are carried up to the Arctic and back around, and they're carried over to England too. And England is kept warm by the thermohaline circulation, and the thermohaline circulation could be totally shut off by different concentrations of CO2 in the atmosphere.
All right. But wouldn't we just say right off the bat, we wouldn't even have differences in weather if it wasn't for the sun. So wouldn't you say the sun would be the number one?
So the sun is extremely important. I agree. But there are some, there's some things we need to lay down about that. Like, for example, yes, the sun does keep us warm, but more important than the sun is the CO2 in our atmosphere, because if we didn't have any CO2 in our atmosphere, the sun would not provide enough heat energy to keep us warm.
It wouldn't hold it down.
Yeah, it wouldn't hold it down. And furthermore, at night it would be extremely cold. During the day, it would still be cold. We're too far away for it to have a meaningful impact.
Okay.
The most important aspect is the CO2.
Right. CO2 in the atmosphere. Okay, so what about land mass? Does that affect the weather?
Well, yeah. I mean, you have like a mountain, right? And a mountain, and you have water vapor in the air. And of course, you have warm air holds a lot of water, so warm air will kind of rise a bit, and it'll run into a mountain, and then it'll rise because it has to. And as it rises, it'll reach a point where it'll get cool enough for water to start condensing. And as water condenses, they give off heat, and that causes the water molecules to rise more, which pulls up more air, so that more water condenses, and then that pulls up more air and more air.
It just becomes a whole cooling process.
Like Seattle has lots of rain because they have a huge mountain range.
Right.
And they're up north.
And they got that,
So,
Okay. Then you had latitude. Latitude, is where you are located on the planet.
Latitude is, if I'm not mistaken, I believe latitude goes that way.
Right.
That is also pretty important, but I would beg to differ that while that is important, I'd say that without atmosphere, all these places would be frozen.
Okay, so but up north and the South Pole, they're both relatively cooler, and I would say the sun hits almost on equal terms up there, but we are getting the lesser light.
I would not say that, because you have to remember the Earth.
Right.
The Earth isn't just a sphere with, axis here, and the sun's over here. No, the Earth has a tilt, a very specific tilt value that is 23.5 degrees.
Okay.
23.5 degrees. So, you have the North Pole and the South Pole. So, we know about how 6 months out of the year the North Pole...
So is this the Milankovitch cycles?
This has partially to do with it. This is more important for seasons.
All right.
When you're dealing with the Earth's tilt, we know that 6 months out of the year the Arctic Circle gets daylight, and then 6 months out of the year they get nighttime. And that's because the sun, when it shines its rays, the equator gets the most of the rays.
Right.
It gets hit dead on. And then 6 months out of the year, the sun is shining its rays directly on this. So the sun is shining in such a way that it'll never set. It'll get close to the horizon, but it'll never actually set. And this is set in such a way that it's blocked by other land masses.
Okay.
Right? And based on how much sunlight we're getting, you'll notice that, we'll have more daylight or more nighttime. So we have, up here, they'll be getting winter, because less of the sunlight is hitting them.
Ooh,
But over
5
here,
minutes,
they're
yeah.
tilted more towards it, so they're getting more sunlight.
So let's go to the other one then. The water, the ocean. How much does the ocean affect weather?
Well, as I mentioned before, they have the thermohaline circulation, which works by, we have warmer water down here. It's a lot less dense, so it floats up towards the north where things are cooler, and it's less dense. But because, salt water is very dense, it sinks below fresh water, and that causes, currents, so it'll carry the heat up to the north to keep it from freezing too fast, and it carries heat over to England, so England stays warm in several countries, and ecosystems are extremely dependent on the thermohaline circulation. But again, the thermohaline circulation is driven by CO2 in the atmosphere, which keeps us warm enough so that we can have the equator be warmer than the North Pole or the South Pole. But it is extremely important. If this shuts
I
off,
thought like the North Pole and the South Pole were covered because the ice is up there, and so therefore bouncing the photons that hit it.
I mean, that is important, you're right, because if you look at albedo, which is the reflectivity of an object,
Right.
1 being ultimate reflectivity, 0 being no absorption, or no reflection. So ice has about an albedo of 0.9, which means it reflects like 90% of the light that hits it, whereas water has an albedo of somewhere around 0.09, which is, very, very low.
That's
obviously.
very low.
So, obviously you replace ice with water, you absorb more heat and all that.
Okay.
But it doesn't mean that...
And it's darker, right? So,
it's darker, so it absorbs more heat, and then that causes a chain reaction. But in the same sense, you can have ice do the same thing and, reflect more light. But the thing is you can still have ice melt. Ice can still do that, obviously. If you get the Earth's temperature above freezing level, then you have problems, because it doesn't matter how much light it's reflecting, it'll still, down here can absorb heat and send heat up there.
Yeah. So the center of the Earth just gets the higher quality of the
higher,
photons hitting, or the light.
Because it's
the light. You were one time talking about that they have different kind of shades of light. Some are more intense and some are less intense.
The sunlight hits down here a lot in the summer, and then it hits a lot less up here in the winter. But year-round, the equator is getting hit constantly, nonstop. Same amount all the time, every day.
So you're saying the whole Earth gets the same amount of photons that hit it, give or take?
Roughly.
Okay. So then the only differences that make it is then, what is in our atmosphere. Is it holding in the heat more?
Yeah. CO2. Like greenhouse gases in general.
Right, greenhouse
There
gases.
are a couple. There's CO2, CO1, which is carbon monoxide. Well, that's just CO. H2O, water vapor, is actually it's a compound that traps heat. Methane, which I don't know the compound form for, but methane. These are all crucial, but the main, of course, is CO2. CO2 is our main.
Yeah, because with CO2, we're talking about parts per million.
Yeah.
And with, let's say, methane, we're talking about parts per billion. That is a huge difference.
Yeah.
All right.
So, but I have to stress that while CO2 is important for keeping us warm, too much of it can very easily destroy ecosystems. It's excruciatingly important that we keep it in check.
Right.
So.
Okay. All right. Cool. Thanks.